Alright, let us start now with 82. The question says, a radiation of wavelength lambda is incident on a photocell. The fastest emitted electron has a speed v. If the wavelength is changed to 3 lambda by 4, the speed of the fastest emitted electron would be what? Logically, we know that if the wavelength is made half, the frequency is made double, then in that case, the kinetic energy becomes more than double. Okay? So, straight away we know that answer would be more than the increase that you have done. So, the answer should be 4. But still, we write the equation of Einstein, which says that 1 by 2 mv square. This is the maximum kinetic energy. Now, that is equal to hc by lambda, that is incident energy, minus the minimum energy that you have to spend in bringing an electron out, that is work function, that is minus phi. So, hc by lambda, if I so desire, I can write as 1 by 2 mv square plus phi. And now, when I write the new equation corresponding to the new speed, hc, the lambda has become 3 lambda by 4, so this can be written 3 lambda by 4 minus phi. So 1 by 2 mv square, v1 square can be written as 4 by 3 of this term, that is 1 by 2 mv square plus phi, and then I have a minus phi. So 4 by 3 phi minus phi can be written as 1 by 3 phi. This is 1 by 2 m v1 square, and this term is 4 by 3 of 1 by 2 of m v square. So you can cancel few terms. You can write a 2 here, and you can maybe divide it by m, okay, and then you can cancel 1 by 2 in m terms, okay. So v1 square will be equal to v square 4 by 3 plus you will get 2 phi by 3m. So obviously you can see v1 square is greater than 4 v square by 3 by this term. So the correct answer would be v1 would be greater than root 4 by 3v, because this term will get added to this. If this was only this much, v1 would be root 4 by 3v, but this term will get added to this. That gives you the answer corresponding to this, that is answer number 4. So the correct answer for this will be 4th, and this was problem number 82. Okay. Next question is from SHM, which says that a particle performs SHM with amplitude A. Its speed is trebled at an instant when it is at a position 2a by 3 from the equilibrium position. The new amplitude of the motion would be what? Right. What is the kinetic energy? Kinetic energy we know very well, that is kinetic energy is equal to 1 by 2 m omega square a square minus y square. What is the potential energy? We know is 1 by 2 m omega square y square. Right? What is the position today? 2a by 3. So what is the kinetic energy? Kinetic energy would be 1 by 2 m omega square a square minus 4a square by 9. 2a by 3. So this will be 4a square by 9. Let us solve this. This becomes 1 by 2 m omega square. 9 minus 4 will be 5a square by 9. This term is your kinetic energy now, and the potential energy that corresponds to this is 1 by 2 m omega square 4a square by 9. This is the potential term. Now what have you done? You have trebled the speed. If you have trebled the speed, the kinetic energy will become 9 times. So the new kinetic energy will be 9 times of this. That will be new kinetic energy. K prime will be 1 by 2 m omega square 5a square. So 1 by 2 m omega square and 5 times of this, 5 by 2 m omega square a square. This 9 you can lose with that tripling term, so 9 times will be the kinetic energy. The potential here is 1 by 2 m omega square into 4a square by 9, but the new total energy would be equal to 1 by 2 m omega square. Mu is, let us say, a1 square. 1 by 2 m omega square, 1 by 2 m omega square, 1 by 2 m omega square you can lose. 5a square plus 4a square by 9 is equal to a1 square. Solve this. 45 plus 4, that is 49 a square by 9 would be equal to a1 square, so a would be equal to 7a by 3. and that is answer number 3. So that is answer number 3 for this particular question, right? Okay, let us go to the next problem. Next problem is from rotation. It's not exactly from rotation. You can say it's a problem based on cross product, more than that. Particle M is moving along a square of side A, the uniform speed v, and xy plane as shown in the figure. So this is the figure. This is moving like this, right? And this is given to you as r, and the angle there is 45 degrees. So this angle is 45. This is A, this is A, this is A, and this also is A. This is x, and this is y. That's for the question, right? And what is he trying to tell you? He's trying to ask you the momentum. Let us calculate the momentum for everything so that it's easy. Angular momentum. So if I look at the r, I can break this r like this: r by root 2 in j direction. That is, this will be the r here, and there will be r here. That will be r by root 2 in I direction, right? Now the particle has a speed v and it is moving like this, right? So now look at it. What is the momentum here? mv. Which direction? I cap. What is the momentum here? mv. Which direction? J cap. What is the momentum here? mv. Which direction? I cap. What is the momentum here? mv. In which direction? Minus j. Right? This part is okay. Now what is the distance here? The distance corresponding to this is r by root 2. The distance corresponding to this is a. What is the distance corresponding to this? R by root 2. And what is the distance corresponding to this a? So in this type of problems, first look at the directions. First look at the directions. You see, if something is moving like this from D to this point A, so this is A, B, and C, and D. So when it moves D to A, it goes like this, and you try to do this perpendicular distance is r by root 2, this, so this should go into the board. So this should be minus k. So minus k, if you look for the options, if you have all the questions, there is only one minus k, then that is correct. And if there is no minus k, that means that answer is wrong. But in this question, what is happening is, I calculated and I got 2 answers correct. Okay, so they have messed it up here. Maybe in one option they have given r by root 2 minus a. In that case, the particle would not be somewhere here, it will come down. That is not possible. That is sure correct. Incorrect, that is 1. 1 is incorrect. And if you look at the third option, mv by root 2 r k cap, and we just discussed from D to A. D to A, if you come, this has to be minus k. If this has to be minus k, then 3 also is wrong. Now I do not know how are they going to see this. If somebody marks both 1 and 3, then the OMR machine will throw that out. I mean, that will make the question invalid. And if somebody marks 3, he should get marks, somebody gets 1. So there should have been a proper proofreading of this because of the nature of the exam. So many people aspire for it. The CBSE should be urged to be more careful on this. Okay, let us look at more problems. Remaining ones, I know the time is a constant, but let us be quick about this. 85th problem, I think we take 85th. An ideal gas undergoes, okay, simple problem. Polytropic process, many times we have talked about it. PV to the power of X is constant. What is the molar specific heat C? How do we calculate? We know this. What is C? C is delta Q by N delta T. Now delta Q itself is what? That is delta U plus delta W. But you know one thing, delta U by N delta T. This is our friend CV, which is written as 1 R by gamma minus 1. Right? And then you will have another term there that will be delta 1 by delta T N. Right? Straight away think about PV to the power gamma process. What is the work done there? The work done there comes out to be R divided by 1 minus gamma, and then you have P1, V1. If you write in terms of temperature, then it comes out to be dt, T1 minus T2 term. So we know the answer for this straight away. C can be written as CV, that is this part, plus the work done part, that is equal to R divided by, here they will give an N, so this will be 1 minus N. So I think I can straight away write it like this: C minus CV is equal to R 1 minus N. I shift it here and write R divided by C minus CV is equal to 1 minus N. So N would be equal to 1 minus R divided by C minus CV. and then n to be equal to C minus CV minus R divided by C minus CV. And we know one thing, that these can be substituted. N is equal to C minus CV divided by C minus CV minus R. Now Cp minus Cv is what is R. So obviously this plus Cv and Cv will lose, N will be equal to C minus Cp divided by C minus Cv. So this is straightforward application of the formula of polytropic process. In every year I stress on this, that someday they give you a question on this. You straight away think about this formula, that is the formula goes like this: C is equal to R gamma minus 1, this is Cv part, and R divided by 1 minus X. And if you forget, you can always cross check. For your isothermal process, if you look at the isothermal process, PV to the power 1. So PV to the power 1 will make this 1, R1 minus 1. So this becomes infinity, and you know the molar specific heat of a isothermal process is infinity. And if you come to the adiabatic part, gamma, so if you put a gamma here, C and C becomes 0, because delta Q itself is 0. Okay, so there are limiting conditions, and then can be made. If you forget that what comes before and what comes after, so you can work it out like that. Next question is from practicals, that is from the screw gauge. And the screw gauge problem actually is telling you what? Let me explain. This time the least count can be calculated very easily, 0.5 and 50. So this is the same good old screw gauge that you use in your labs. There the resolution is 0.01, that is 1 millimeter divided in 100, it is 0.5 divided in 50, so 0.01 millimeter. But the issue here is there is an error in this. Okay, what would happen? This says that the zero line coincides with the 45th division. If it coincides with the 45th division, you are basically having a negative error of 5. The error is always subtracted, remember. And the correct reading it is giving you, I mean the measured reading there is 0.5 and 25. So I can straight away write 0.5 plus 25 into 0.01 minus 0.05, because if you take the correction, this will be plus, this will be added. Otherwise, this will be subtracted, and minus and minus will give you plus. So the answer would be 0.5, 0.25, so this will be 0.80 millimeter, and that answer would correspond to 1. That is your answer.